Hello and welcome to my presentation. I am Bertus Jordaan and I will be presenting about predicting genres from song properties. This presentation is part of the IBM Advanced Data Science Capstone course, and it consists of two parts. The first part is the overview or the stakeholder presentation. The second part is the technical part or peer presentation. I hope you enjoy. So let's get started. So let's start with the data. The data is from kaggle.com and it's a data set of Spotify songs of over 160,000 tracks. The features are acousticness, danceability, energy, etc. Two tables are used. One comes from aggregating by artist, and then you get around 30,000 observations. And the other one is when aggregated by genre, and then you get around 2,600 observations. The distribution of acousticness in the artist table can be seen on the right side, and also danceability. These two distributions are quite different and are representative of the different features, different distributions. The use case is to determine whether or not these song attributes can be used to predict a genre of a song. More specifically, an artist, since we use the aggregated by artist dataset. It stands to reason that a consumer on a platform such as Spotify would like to get a deeper sense of what kinds of songs they like, and I believe that identifying the genre gives them this opportunity. The solution is based on two pillars. The first pillar is that uncategorized or unlabeled genres dominates the algorithms and leads to bad accuracy. And secondly, genre similarity also makes the multi-label problem even more difficult. Clustering into supergenres therefore improves the performance. The final multi-label classification was done using a k-nearest neighbor classifier and a convolutional neural network. Convolutional neural network outperforms the KNN on key metrics. Suggestions on how to improve this is to use natural language processing on music reviews to help create the supergenres and combine the genres into them, or gaining more information on the individual songs, such as fast-forwarding transform information. Now for the technical details. The architectural decisions I made is that the coding platform is IBM Watson Studio. The machine learning libraries is scikit-learn and TensorFlow Keras, and the storage is IBM Cloud Object Store. Feature engineering was a dominating task since it was done iteratively as downstream information from models were added to the feature engineering task. 5 layers can be identified. The first one is cleansing and encoding. This was just the very basic removal of genres that didn't appear in the genre table and encoding the sets of genres using multi-label binarizers as encoded vectors. Then the second part is using principal component analysis to reduce the features from 10 to 6 and reducing the total table from 30,000 to 20,600 because we can remove a lot of negative information observations that are unlabeled and or labeled to this empty class. An additional label set reduction was done by reducing the data set to only the 50 most prevalent genres. This reduced the total number of observations to 5,669. In order to do the genre super clustering, genre PCA was done. Again, the features were reduced from 10 to 6. And after the super genre clustering was done, the sorting of the labels into these 10 super genres was done. Now the model definitions. We have two k-nearest neighbors models. The first one was used on the initial data set, and the neighbors was set to 10. The second one then was used on the super genre data set, and the nearest neighbors were set to 5. This is very simple models, but they allow for multi-label classification, and that was why I chose them. For the clustering, I used scikit-learn's agglomerative clustering. The number of clusters that optimize key performance indicators was 10. And here on the right hand side, a two-dimensional visualization shows a good balance of the genres in the basis set. For the deep learning models, it's a very simple multi-layer perceptrons for the two models with different epochs, which is the distinguishing factor. Importantly to notice is that in the middle, I have a layer that increases in the number of densely connected neurons and is activated by sigmoid. This led to modest improvement and was based on the intuition that there is an interconnectiveness between the output labels. The important thing for multi-label problems as opposed to multi-classification problems is that the activation of the output layer needs to be sigmoid and the loss needs to be binary cross entropy. For the multi-layer perceptron of the supergenre case, it's very similar as before. The only thing is that I added a different loss function that is from a library. This back propagation of multi-label layered labels loss. And for the convolutional network, there's convoluting layers and a pooling layer, and the optimizer is changed to Adagrad as opposed to stochastic gradient descent. The evaluation is based on 3 metrics: accuracy, Hamming loss, and at least one correct. The accuracy is a good metric to give an overview of the performance, but it is very strict as it gives a percentage of the label sets that are accurately predicted. The Hamming loss is a little bit less strict because it gives the number of labels that are wrong. The at least one correct label metric is a customized metric that I created for this project. Since the goal is to classify a genre, we determine what percentage of the predictions gives at least one correct label. And here is the results. The graph shows the different metrics with light green as accuracy, dark green as Hamming loss, and black as at least one correct. The influence of the creation of the supergenres is clear from seeing how better the last 3 models perform than the first 3. Moreover, the 3 supergenre models gives more than 50% scores for the at least one metrics. So it gives a starting point for this deeper understanding that we wanted from this. Finally, the convolutional neural network has the best combination of accuracy, low Hamming loss, and high at least one metric. So that one would be a good one to develop further. The final product of this project is a static notebook that summarizes what was presented in this presentation. And with that, I would like to thank you for your attention.